Hi, I'm Andy LeGrand. Welcome to our program. Today we're going to plug into an electrifying topic and learn how to avoid shocking experiences. Electricity is all around us. It lights our workplace, powers machinery, and kickstarts our tools. Without it, daily operations would grind to a halt. But electricity can also be dangerous. Electrical accidents can damage equipment, start fires, and cause injuries like burns. And of course, electric shock. We need to exercise caution whenever we're around electricity. Getting to know electricity inside and out is the only way to be safe. Let's start by reviewing a few fundamentals. Current is the flow of electricity, which is measured in amps. Most household and industrial lines can safely carry 15 to 20 amps. Electrical lines can hold more current if their wires are thicker. It doesn't take much current to cause a serious injury. In fact, contact with the amount of electricity needed to power this Christmas tree bulb can be fatal if it passes through a person's heart. Volts is another word we hear a lot about. Volts measure the force behind the current that is flowing. In North America, most power tools and household appliances run on about 120 volts. Equipment requiring more power often operates on dedicated lines. Like amps, the higher the voltage, the greater the danger. Let's take a look at the electrical system and learn to work with it safely. Electricity flows when a loop, electricians call it a circuit, is completed. This loop is the uninterrupted passing of electricity from the power source through the equipment and back again. When the circuit is complete, our tools and machinery are powered up and ready to go. To regulate the loop, tools and machines have an on and off switch. When the switch is on, the circuit is complete and electricity will flow. Moving the switch to the off position breaks the flow of electricity and stops the equipment from running. To protect tools and equipment from damage, the electricity can also be broken by a fuse or circuit breaker. These devices stop the flow of electricity when wires become overloaded and heat up. Don't attempt to override this system by installing higher-rated fuses or breakers. This will allow too much electricity to pass through the lines and increase the potential for accidents. If a breaker has tripped, talk to your supervisor before switching it back on. You may need to lighten the load on the line. Another important principle to remember is that stray electricity always heads toward the ground. Here, the electrical charge is safely neutralized. Unfortunately, this can lead to a nasty shock if you're in its path. Controlled grounding provides us with a safeguard. If electricity leaks through cracked or defective wiring, the ground wire will direct the electricity back to the ground. You can see the ground wire easily in three-pronged plugs. In order for a ground wire to be effective, the outlet that it's plugged into must be connected to ground. But just because an outlet can take a three-pronged plug doesn't necessarily mean it's grounded. The only way to be certain that the outlet is grounded is to test it. For added safety, outlets can be fitted with a ground fault interrupter, or GFI. This device can be a lifesaver. It immediately shuts off the flow of electricity when it senses a change in the strength of current. For instance, if a defective tool leaves you vulnerable to a shock, the ground fault interrupter will stop the electricity before it has a chance to hurt you. Following safe work practices is critical to working safely around electricity. To begin with, we need to remember that electricity can be dangerous, just like the signs say. Electrical hazards most often result in fires, shocks, and burns. Be on the lookout for the conditions that can cause these problems. A number of accidents are the result of faulty wiring. Before plugging in a piece of equipment, check the insulation on all power cords for cracks and other defects. Report any problems and have damaged cords replaced or serviced immediately. Don't overload circuits. Drawing too much current will cause the wiring to heat up and increase the risk of an accidental fire. Limit the use of extension cords to temporary setups. And be sure to choose an extension cord that can handle the amount of electricity you're going to use. Drawing too much electricity through an extension cord will cause it to heat up. Overloading the cord may result in cracks and other defects which can lead to shocks or even fires. Remember that all electrical equipment should be properly grounded. If you're using an adapter with an old two-prong outlet, don't forget to connect the ground wire. Never alter three-pronged plugs to fit into two-pronged outlets. This prevents stray electricity from heading to ground and leaves you vulnerable to a shock. Play it safe. You also need to exercise caution when selecting electrical equipment. Use double insulated tools whenever possible. They have built-in protection against the hazards of shock. In the event of a problem, the special safety shielding inside these tools conducts stray electricity away from you. Sometimes equipment may appear to be working properly, but when you take a closer look, you may find a problem. For instance, a machine with damaged connections can throw off tiny sparks. Be careful. Sparks can start a fire. Tell your supervisor about any problems and contact a repair person. Unless you're qualified, don't try to fix it yourself. Qualified workers who need to open up machinery regularly disconnect all power sources before making repairs or adjustments. This means practicing proper lockout-tagout techniques. If a machine has been locked and tagged, don't try to restore power before all the necessary repairs have been made. And never override special safety devices like electrical interlocks, which keep the machine from turning on before it has been properly unlocked and tagged. Consult your supervisor if you have any questions about lockout-tagout. Wherever you're working with electricity, you need to have enough light to see what you're doing. This is especially important if you're working on energized parts. Never reach blindly. What you can't see can hurt you. If you're making a repair, take the time to bring a light over so you can see what you're doing. Some of the things that we wear can conduct dangerous amounts of electricity straight to us. Watch out for keychains, metal jewelry, and other conductive objects. Simply placing these items in your pocket won't prevent them from conducting electricity. If you're working around energized lines or machinery, the best course of action is not to wear conductive articles at all. Good housekeeping is also important to the safe operation of electric tools and equipment. Excess grease and debris should be cleaned up so that motors don't overheat. And remember, don't use conductive materials like liquids, steel wool, or even metal hand tools near energized parts unless you take the proper precautions. Guarding against shocks often means using safety equipment like insulated gloves and hard hats. Ask your supervisor about the equipment that's right for the job you're doing. Some work environments have their own special hazards. In these situations, extra caution is required. Water and electricity are a dangerous combination. Water conducts electricity. Its presence can leave you vulnerable to a shock. Never plug in cords that are wet, and don't touch electrical equipment if your hands are wet. If you encounter water, try to remove it before you begin work. And remember to use safety devices such as double insulated tools and ground fault interrupters. They're especially important in these situations. With little room to maneuver, confined spaces can be cramped and dangerous, especially where live wires and electrical equipment are present. If you're working in a confined or enclosed space, you need to take special precautions. To avoid accidental contact with energized lines, you should insulate electrical materials and use protective shields and barriers. Keep hinged panels and doors secure so that they don't release and knock you into an energized line. Working close to high voltage power lines can be extremely dangerous. If you're working around these lines, it's important to remain at a safe distance. In many cases, the lines will be de-energized for added protection. Don't use metal ladders when working near power lines, electrical wiring, or energized machine parts, no matter what the voltage. The metal will conduct stray electricity straight to your body and could give you a nasty shock. Instead, use a fiberglass or wooden ladder with non-conductive side rails. Remember, only qualified workers taking the proper precautions may actually work on high voltage lines. If you're not qualified, you and any conductive object that you're holding cannot come within 10 feet of a power line carrying 50,000 volts. For higher voltage lines, you must stay even further away. These clearance distances also apply to vehicles and other equipment that come near overhead lines. If you have any questions, ask your supervisor. In areas where flammable materials exist, it is especially important that you choose your equipment carefully. Avoid using tools and machinery with motors that spark. These could create dangerous sources of ignition. If there has been a leak of a flammable gas or vapor, do not turn equipment on or off. This might create an electrical arc, which could result in a fire or explosion. Wait until the atmosphere is clear of flammable vapors before using any electrical equipment. Electricity is a powerful asset, but only when we use it safely. We need to follow safe work practices. Use the protective equipment that's right for the job. Inspect tools for cracked cords and other defects. And report any unsafe conditions. Remember not to attempt repairs unless you're qualified to make them. By now, none of this should come as a shock. You can avoid accidents by taking the necessary precautions, participating in training sessions, and of course, remembering to work with electricity safely.